So given this given this logical function which is here, so how can you find the derivative of this logical function? So in order to find the derivative of this logical function, what you have to do is that you have to use the chain rule. So the first step is that you have to write this square root. So this square root will be 2, and this one here on top is the power a, which is the invisible power of x, which is 1. So it will be like this. So after writing it in this form, and then we can use the power law and the chain rule combined. So it will be, so the next step will be you have to take these 2 in front, 1 over 2 in front a, and then write what is in the inside. So it will be 1 over 2x raised to the power 1 over 2 minus 1 times the derivative of the inside part. So the inside part is x, and then what is the derivative of x? So the derivative of x is therefore positive 1, like that. So positive 1 times 1, which is a, it is just 1. So this whole expression will be like this. So 1 over 2 minus 1, which is negative 1 over 2 over 2, like this to a, like that. So at this stage now, since this variable, this x variable has a negative exponent, which is negative 1 over 2, we have to take it to the bottom, and then to be a 1 over 2, and then this variable will come to the bottom like this, and then if we take it to the bottom there, the sign will change from negative to positive, so it will be 1 over 2, like that. So after writing like this, we have to take it back into its logical form, so it will be 1 over 2 the square root, and then the square root of x, like that. So this is how we can find the derivative of this logical function. So this is the answer. So let's move on. Let's try example 2. So what's the derivative given this function? So let's say we have, let's just say x plus 2, like that. So how can we find the derivative of this function? So just like before, what we have to do is that we have to write it, so it will be x plus 2 in brackets, like that, and then write this square root to be 1 over 2, like that. So after writing like this, we have to take this exponent to the front, so it will be 1 over 2 open bracket x plus 2, like that, and then subtract the exponent, subtract 1 from the exponent here, so it will be 1 over 2 minus 1 times the derivative of the inside part. So the derivative of x plus 2 is just 1, like that, just positive 1. So this expression will be 1 over 2 open bracket x plus 2, and then 1 over 2 minus 1, which is just negative 1 over 2, and then 1 times 1, just 1, like that. So this expression will be like this. So it will be x plus 2 raised to the power negative 1 over 2 over 2, like that. So since this function a has a negative exponent, we have to take it back to the bottom. So it will be 1 over this 2, which is here, so 2, and then x plus 2 in brackets, like that. And so since a is negative, and then when this exponent comes down to the bottom, it will change the sign to be positive, so it will be 1 over 2, like that. So taking this back to its logical form, it will be 1 over 2, and then the square root of x plus 2, like that. So this is how we can find the derivative of this logical function using the chain rule. So that's the answer. So let's go on, let's move on. Let's try question 3. So let's say we have let's say d dx, and then we have the square root of x cubed plus 6, like this. So the same, we're going to apply the same step. So the first thing we're going to do is that we're going to write this function. So we're going to write it like this. So it will be x cubed plus 6 in brackets like this, and then we are going to it will be 1 over 2. The power will be 1 over 2, like that. So after writing this, and then you can apply, then you can go ahead and apply the power on the chain rule at the same time. So it will be 1 over 2. So we're going to take this exponent to the front. It will be 1 over 2 open bracket x, and then you have to write what is in the inside. So it will be 3 so it will be x cubed plus 6, like that. And then after writing what is in the inside, you have to subtract 1 from the exponent. So it will be 1 over 2 minus 1 times the derivative of the inside part. So the derivative of this function, which is in the inside, will just therefore be 3x squared, like that. So 3x squared times 1, which is just 3x squared, like that, and then x cubed plus 6x, and then here 1 over 2 minus 1, which is just negative 1 over 2, like that, and then over to this 2a over 2. So after writing it like this, so since here this function here, this function has a negative exponent, I'm going to take it back. I'm going to take it to the bottom. So it will be 3x squared over 2, this 2, and then x cubed plus 6 raised to the power positive 1 over 2, like that. So taking back this to its logical form, it will be 3x squared over 2, and then open bracket, and then write the square root like this. So since here we have 2, I'm going to write it like this. So it will be x cubed plus 6, like that. So this is the answer. So this is how you can find the derivative of this logical function. This is how we can find the derivative of logical function using the chain rule, like that. So let's try 2 more examples. So let's just say we have this function. Let's make it a bit different. So it will be d dx. So d dx, and then let's just say the cube root of 6x squared plus 2, like that. So again here what we have to do is that we just have to rewrite this. So it will be 6x squared plus 2 in brackets, and then since here we have these 3, it means that we have the cube root. So if you don't see any index number here, it means that you have the square root. So it will be 1 over 3, like this. So after writing this, you are going to bring this exponent to the front. So it will be 1 over 3 open bracket 6x squared plus 2, like that, and then subtract 1 from the exponent here, minus 1, and then after subtracting 1 from the exponent, and you have to multiply this function time by the derivative of, we have to multiply it by the derivative of the inside part. So the derivative of the inside part is therefore 12x. If you differentiate this inside part to give you 12x, like that. So 12x times 1, which is just 12x. 12x, and then here we're going to say 6 squared plus 2 is the power, and then here what is 1 over 3 minus 1. 1 over 3 minus 1 is to give you negative 2 over 3, like that, over this 3 which is here. So since here we have a negative exponent, we're going to take this expression in brackets down to the bottom. So on top we're going to have 12x over this 3 which is on the bottom already, and then this will come down. It will be 6x squared plus 2 less the power positive 2 over 3, like that. So taking this back to its logical form, it will be 12x over 3 6 squared plus 2, like that, and then in brackets. So this 3 will turn into this logical to be a cube root, and then this 2 will be the power, so it will come here, so it will be this to the power 2. So that's how you can find the answer. So that's how we can differentiate this logical function. So it will be like that. So this is therefore the answer. So let's do one more example. So let's say we have dx. Let's say we have 2 over the fifth root of x squared, like that. So how can we find the derivative of this function? So again, here what we have to do is that we have to rewrite it. So I have to write the denominator here, so it will be x raised to the power 2 over 5, like that. Then after rewriting this, we're going to take this x raised to the power 2 over 5 here on top, so it will be 2x raised to the power 2 over 5, and then after writing this you have to add negative since it is coming from the bottom and going up, like that. So after writing this, so this will be the inside function, x will be the inside function. So you have to take this negative 2 over 5 to the front, so it will be negative 2 over 5 times 2 open bracket, and then you write the inside function. The exponent will be negative 2 over 5 minus 1 times the derivative of the inside part. So the inside part here we have, which is x. So the derivative of x is therefore 1, like that. So the derivative of x is therefore 1. So negative 2 times 2, which is 4 x raised to the power. So negative 2 over 5 minus 1, which is negative 2 over 5 minus 1 will give us negative 2 over 5 minus 1 will give us it will be negative 2 over 5 will give us negative 7 over 5, like that. So over 5, so this will be negative 4, like that. So again here, since this x variable has a negative exponent, we're going to take it back to the bottom, so it will be, we're going to take it to the bottom, so it will be negative 4 on top, and then on the bottom it will be 5 x raised to the power positive 7 over 5, like that. And then taking back this to its radical, this x raised to the power 7 over 5 to its radical form, it will be negative 4 over 5, and then this 5 will become the fifth root, like that. This 7 will become the power a, and then we are going to write x, which is the inside function, like that. So this is the answer. So this is how we can find the derivative of this rational function. So that's how you can find the answer.